Consider this alkyl halide in which chlorine is on wedge. Draw the same molecule with chlorine on dashes. As per IUPAC rules, both these molecules will be called 2-chlorobutane. And if we put a mirror in between these two, we will find that these two are mirror images of each other. In other words, if we look at the molecule from front side, we will see this molecule with chlorine on wedges, whereas a person looking from the opposite side will see the chlorine on dashes. In other words, we can say, these two are enantiomers or non-superimposable mirror images. Thus IUPAC name of enantiomers are same. Thus, a question arises how to distinguish these molecules from one another. For this, Cahn-Ingold-Prelog devised a system of nomenclature, called R and S system, which actually gives nomenclature to chiral centers based on certain rules. This system of nomenclature of chiral centers is also called the absolute configuration. As per this system, the atoms or groups attached to a chiral center should be numbered as per atomic number, with higher atomic number getting number 1 and so on. To understand this, consider this molecule. This carbon is the chirality center, as it is attached to 4 different groups. For easy understanding, these groups are shown in different colors. The groups attached are bromine, oxygen, which is attached to methyl making a methoxy group, hydrogen, and a methyl group. As per Cahn-Ingold-Prelog rules, bromine having higher atomic number gets number 1, oxygen is next and gets number 2, carbon gets 3 and hydrogen gets number 4. After numbering the groups, look at the molecule from the direction opposite to the least priority group 4. Then draw an arrow from 1 to 2 to 3, if the arrow moves clockwise, the absolute configuration is R. If it moves anticlockwise, then absolute configuration is S. In this molecule, on moving from 1 to 2 to 3, the arrow goes clockwise, therefore absolute configuration is R. And, if we take the mirror image of this molecule, the hydrogen will appear on wedge and bromine on dashes. In the original molecule, arrow from 1 to 2 to 3 goes clockwise and is designated as R. In this mirror image, the arrow also moves clockwise, but the least priority group 4 is on solid wedge. Since Cahn-Ingold-Prelog rule says, look at molecule, from the direction opposite to least priority group 4. It means, we have to actually look at this molecule from backside, only then least priority group 4 will be opposite to observer. And, we know, a clockwise arrow from front side will appear anticlockwise, if observed from opposite direction or backside. Thus, if the least priority group 4 is on wedges, which means on front side towards the observer, then rather than looking at molecule from backside, we can look at the molecule from front side and reverse the CIP rule. This means that, clockwise arrow now means absolute configuration of S. Thus, this molecule has absolute configuration of S. Therefore, if a chiral center in a molecule has R configuration, then its mirror image or enantiomer will have S configuration on that chiral center. All the chirality centers in enantiomers are inverted. Every R becomes S, and every S becomes R, in the enantiomer. Consider this molecule. Based on CIP rule, among the groups attached, chlorine has highest atomic number and gets first priority. This is followed by nitrogen as second, methylene carbon gets third number and hydrogen gets least priority 4. Here group 4 is on dashes. On moving from 1 to 2 to 3, the arrow moves counterclockwise, which means absolute configuration of this molecule is S. Consider this molecule similar to above, with chlorine replaced by a methyl group. The asymmetric carbon is attached to nitrogen, hydrogen, and 2 carbon-based groups, methyl and ethyl. Out of these carbon groups, this methyl carbon is attached with 3 hydrogens, whereas this methylene carbon is attached with 2 hydrogens and 1 carbon. Thus, methylene gets preference and gets number 2. Methyl gets number 3 and hydrogen of course gets number 4. From 1 to 2 to 3, the arrow moves counterclockwise. Group 4 is on dashes. Therefore, counterclockwise means absolute configuration is S. Consider this molecule. The asymmetric chiral carbon is attached to bromine, hydrogen, and 2 carbon-based groups. Both these carbons are attached to oxygen. Left side carbon is single bonded to oxygen making hydroxyl group. Right side carbon is double bonded to oxygen making carbonyl group. In such a situation, the CIP rule says that, treat double and triple bond as if each were a bond to a separate atom. For example, consider this double bond between a white carbon and pink carbon. It means the white carbon is bonded to 2 pink carbons and pink carbon is bonded to 2 white carbons. Consider this imine, a double bond between white carbon and green nitrogen. It means white carbon is bonded to 2 green nitrogens and nitrogen is bonded to 2 white carbons. Consider this alkyne, with a triple bond between a white carbon and a blue carbon. It means white carbon is bonded to 3 blue carbons and blue carbon is bonded to 3 white carbons. Consider this carbonyl, a double bond between white carbon and red oxygen. It means white carbon is bonded to 2 red oxygens and oxygen is bonded to 2 white carbons. Therefore, in such cases, we have to imagine that each pi bond is broken and the atoms at both ends duplicated. Note that when you break a bond, you always add 2 imaginary atoms. In these examples, imaginary atoms are circled. Now we can assign the priority to the groups in this example. This carbonyl carbon is considered bonded to 2 oxygens and a hydrogen. Whereas, this carbon is bonded to 1 oxygen and 2 hydrogens. Thus, this carbonyl gets preference and hence number 2. Whereas, this carbon with hydroxyl group gets number 3. Hydrogen of course gets number 4. Now, the arrow from 1 to 2 to 3 moves in clockwise direction, with group 4 on dashes. Hence absolute configuration is R. Consider this example. This carbon is asymmetric. It is attached to bromine, hydrogen, and 2 carbon-based groups. Bromine with higher atomic number gets highest priority 1. Out of these 2 carbon-based groups, this carbon is bonded to fluorine, oxygen, and nitrogen. Whereas this carbon is bonded to sulfur. Even if only one atom has a higher atomic number than the highest one on the other carbon, the group gets higher priority. So, 1 sulfur beats nitrogen, oxygen, fluorine because it has a higher atomic number than the others individually. Hence, this carbon gets number 2 and this gets number 3. Hydrogen is of course number 4. The arrow from 1 to 2 to 3 moves clockwise, with group 4 on dashes. Hence, the absolute configuration is R. Carbon is not the only atom designated by R and S nomenclature. In theory, any atom with 4 different groups is chiral and can be described by R and S system. Consider this compound with sulfur chiral center. Oxygen gets number 1. Ethyl gets 2 and methyl gets 3. Hydrogen is 4. The arrow from 1 to 2 to 3 moves anti-clockwise, with group 4 on dashes, therefore absolute configuration of this sulfur chiral center is S. Consider this phosphorus chiral center. Bromine gets number 1, oxygen number 2, ethyl number 3 and methyl number 4. Arrow from 1 to 2 to 3 moves clockwise, with least priority group 4 on dashes. Thus, the absolute configuration of this phosphorus chiral center is R. Consider this example. Nitrogen gets priority 1. Out of these carbon groups, this carbon is attached with a carbon and 2 hydrogens. whereas this carbon is attached with 3 hydrogens. Thus this methylene carbon gets number 2 and methyl gets number 3. Since amino group is on wedges, therefore fourth group hydrogen is to be considered on dashes, which gets number 4. The arrow from 1 to 2 to 3 moves clockwise, with group 4 on dashes, hence the absolute configuration is R. In this case, bromine gets number 1, phenyl ring carbon gets number 2, and methylene carbon gets number 3 priority. Since bromine is on wedges, therefore, fourth group not shown here must be hydrogen on dashes. The arrow from 1 to 2 to 3 moves anticlockwise, with group 4 on dashes, hence the absolute configuration is S. In this example, chlorine gets number 1. Alkene carbon gets priority 2 over methyl carbon, which come on number 3 priority. Since chlorine is on dashes, therefore fourth group must be on wedges, which of course, is none other than hydrogen, if not shown in the structure. The arrow from 1 to 2 to 3 moves anticlockwise, with group 4 on wedges, hence CIP rule is to be reversed. The anticlockwise means absolute configuration is R. In this example, this is the chiral center. These two groups are connected with chiral center via single bonded oxygen. Hence the two groups cannot be prioritized at this stage, because both are same. On the left side, the next is carbon, which is bonded to a carbon and 2 hydrogens. On the right side, the next is a carbon which is bonded to 3 hydrogens. Thus, these two carbons are different, and therefore left side oxygen gets number 1 and right side oxygen gets number 2. The carbon gets number 3. Since oxygen is on dashes, hence fourth group hydrogen must be on wedges. The arrow from 1 to 2 to 3 moves clockwise, with group 4 on wedges, hence the CIP rule is reversed. The clockwise arrow means that absolute configuration is S. In this example, hydroxyl oxygen gets number 1. These two groups have methylene and can't be distinguished at the first carbons. Next is carbonyl on this right side and methyl on this left side. Therefore this side gets number 2 and this gets number 3. Fourth group is hydrogen on dashes. The arrow from 1 to 2 to 3 moves clockwise, with group 4 on dashes, hence the absolute configuration is R. In this example, this carbon is to be considered bonded to 3 nitrogens. This carbon is bonded to 2 carbons. And this carbon is directly bonded to bromine. Thus, this gets number 1, this carbon with nitrogen gets number 2 and this carbon gets number 3. Fourth group must be on wedges and is hydrogen. The arrow from 1 to 2 to 3 moves anticlockwise, with group 4 on wedges, hence the CIP rule is to be reversed. The anticlockwise arrow means that absolute configuration is R. In this molecule, 2 chiral centers are present. Take this one first. The 3 groups on this chiral center have methylene and cannot be distinguished on first carbons. The next carbon on this side is attached to 2 carbons and a hydrogen. This one is bonded to oxygen and 2 hydrogens. And this one is bonded to 1 carbon and 2 hydrogens. Thus this gets number 1. This gets number 2. This gets number 3 priority. Methyl carbon gets number 4. The arrow from 1 to 2 to 3 moves anticlockwise, with group 4 on wedges, hence the absolute configuration is R. On this second chiral center, the first carbon in all 3 groups is same, a methylene group. Hence no distinction on first carbon for 3 groups. On this side, the second carbon is bonded to 1 carbon and 2 hydrogens. Here the second carbon is methyl and bonded to 3 hydrogens. Here the second carbon is bonded to 3 carbons. Thus this gets number 1, this gets 2 and this 3. Fourth group must be on wedges and is hydrogen. The arrow from 1 to 2 to 3 moves clockwise, with group 4 on wedges, hence the absolute configuration is S. In this example, there are 3 chiral centers. Take this one first. Sulfur gets number 1. Nitrogen gets number 2. Methyl gets number 3. Fourth group must be on dashes and is hydrogen. The arrow from 1 to 2 to 3 moves anticlockwise, with group 4 on dashes, hence the absolute configuration is S. Take this second chiral center. Sulfur gets number 1. This carbon is bonded to carbon, nitrogen, and hydrogen. This carbon is bonded to 2 oxygens and a carbon. So this carbon gets priority 2. And this gets priority 3. Since sulfur is on dashes, therefore, fourth group must be on wedges and is hydrogen. The arrow from 1 to 2 to 3 moves anticlockwise, with group 4 on wedges. Hence CIP rule is to be reversed. The absolute configuration is R. Take this third chiral center. Nitrogen gets priority 1. This carbon is bonded to sulfur and gets priority 2. This methylene carbon gets priority 3. The fourth group must be on wedges and is hydrogen. The arrow from 1 to 2 to 3 moves anticlockwise, with group 4 on wedges, hence the absolute configuration is R.